Okay, awesome. I didn't know what to say in normally my discussions are always my presentations are always 10 minutes. So I was trying to kind of lengthen this presentation, but I hope that I just give a quick presentation and then we have one big discussion and Q&A session as well. So I'm going to be speaking about co-designing virtual reality for Indigenous knowledge preservation. Just to start with an outline, I'm obviously going to introduce myself, even though Tarek already gave me such a lengthy introduction. I'm going to introduce also the IK cluster to which I work under. And I'm just going to briefly discuss on the 7C model that we kind of use to co-design with the communities. Then I was kind of told to kind of share with you the first big project I was part of, which was the gesture co-designing with the community, and what I'm currently doing now for my honors thesis, which is the virtual learning experience. Then we can go into a conclusion in a quick Q&A. So about me. So my name is Selma Ndapeua Omagano Auala. So Ndapeua Omagano are my traditional names, and Selma is kind of the name the English name that we kind of call. So I'm a kind of an early career HCI researcher and a software developer. So I finished my bachelor's in computer science last year, and I majored in software development. Currently, I am an honor student under the research bracket of Indigenous knowledge preservation, and I have kind of worked on multiple co-design projects, including co-designing with children in Indigenous knowledge. And if you look at the end when we discuss my honors, you kind of look at how I kind of bridge both, because I co-design with the children and Indigenous community for my honors. So since 2008, the IK cluster of the Namibia University of Science and Technologies has kind of been creating representations and digital cultural experiences of, 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 of the different community, of the two indigenous communities that we have, to kind of create or to capture the essence of these communities. So the IK cluster has been engaging the Ovahimba and the San to kind of preserve their indigenous knowledge, their stories, their tradition through digital cultural experiences, with the primary focus on virtual reality. And currently we have two fully functional VR applications for the Sun community. And I'll later introduce a new one that we're currently busy developing that is also as part of my honors. So the IK cluster developed or established this 7C framework for the digitalization of this indigenous knowledge, which kind of have the 7 stages, mainly the co-design, conceptualization, collection, correction, curation, circulation, and then the creation of this knowledge, right? So this whole framework is what we all kind of use to kind of digitalize all the indigenous knowledge into whatever digital medium that we choose to use. So now I'm going to go into the community-based exploration into gesture-driven locomotion control in virtual reality. So locomotion has kind of become a very common feature within virtual reality as some kind of method to move and explore in the virtual world without kind of necessarily moving or occupying space in the real world. So now there's kind of been extensive research on locomotion in VR with a focus on interaction techniques and the presentation within the virtual environment. So further considering side effects such as cyber sickness and the increased discomfort of wearing head-mounted displays. Sorry? Oh, I thought that was a question, maybe. Sorry. While there are many techniques that can kind of be used to initiate locomotion, controllers have kind of been the most frequent choice so far. But because of the new technologies which are supporting hand tracking, controllers might become obsolete. Okay? Thus, the gesture-based interactions are being increasingly investigated. However, only a few studies have explored locomotion. So besides gesture control, some alternatives have kind of explored the use of feet, eye wink, mouth gestures, and kind of so on. So most of these emerging technology interaction techniques are developed in labs with no or little end user environment involvement, leading to this non-intuitive gesture, such as the most obvious one, the pinch. Now, in order for us to create more natural interaction techniques, it is important to kind of involve end users in the design and the validation of these techniques. Now, although the number of user-driven gesture design studies is increasing, there's still minimal, exploration of user-driven gesture design for locomotion in VR, considering that the diversification of VR applications and its users, yet technology developments maintain this prevalent biases, and we argue for an increased inclusion of participants previously excluded from the technology the design. So just to introduce you, for this study, our partners is the Donkerbo San community. So the San Tuhansi Donkerbos community are located in the eastern Namibia and is one of the many marginalized San communities. The San community make up roughly 1.18% of the population in Namibia, and I consider to be part of the oldest tribes on the African continent. They were traditionally hunter-gatherer nomadic people. So looking at the community member participation, for this research in the study, we collaborated with the Donkerbos community because we kind of have been collaborating with the community and partnered with Aalborg University since 2017. Now, during this, they have kind of jointly been co-designing applications from mobile applications and VR with and without hand tracking. So most technologies developed had the purpose of kind of safeguarding their cultural heritage. Now, despite having collaborated for so many years with the community, their technical experience is at different levels because the community consists of about 200 people in 30 households, and of who individuals kind of attend research sessions when convenient to them. So this means that some people have participated in all the previous VR sessions over the year, while others have not experienced VR before, especially the women, because I believe before I joined the projects, most of the women were not eager to be involved in the virtual reality sessions. So within this study, we kind of co-created gesture interaction techniques with the community with the aim to kind of ensure this local acceptability and suitability and to kind of mitigate these biases from the Western developed technologies. Just an overview of the study process. We had 4 stages, which spanned over 2 years, where we carried out 2 different elicitation studies and then evaluated and implemented locomotion gesture. And then finally, we selected gestures with the community. Just looking in detail into the first elicitation study, we kind of had this setup where we had 12 community members involved to be participants, of which 5 were women and 7 were men. The VR setup, it consisted of a static scene in VR, displaying 3D representation of a traditional San village. So there were 2 dots were placed on the ground. One was green and one was blue, and one was located next to the villages and the other next to the huts. So in this elicitation session, we conducted it with an Oculus Quest 2 with inside-out tracking, allowing for the capture of participants' hands. So this, because we are obviously in the bush, in the field, the session took place under a shaded gazebo for both participants and the VR headset to guard both participants and the VR headset from that harsh sun. So in too much light or darkness, the headset will kind of not be able to recognize the participants' heads. And in terms of facilitators, we had 3 facilitators, one with each specific role, because we had to have someone with the technical setup, we had to have someone be a note taker and the participant guide, and then we have always a translator. Now, the procedure for the elicitation study is that we had an introduction. So participants wore the VR headset with the VR scene and the 2 dots on the ground. So we kind of told the participants, or we kind of asked them, how would they want to move to those 2 dots without physically moving their feet? So the participants were kind of allowed to consider any approach and play around with any idea before showcasing it. So once the technique was showed, the facilitators were asked them to repeat the movements and to capture it on video. So all the participants were asked the same regarding the movement to the dots without the use of their feet. After having understood their assignment and not physically walking closer to the dots, because we did have participants who kind of walked instead of explained how would they go there. The participants kind of started performing gestures with their hands. Then the recorded gestures were later analyzed using a thematic approach, looking for patterns in the participants' movement or group gesture similarity together. With the second elicitation study, we kind of took the results from the first elicitation study, and then we built 2 prototypes in which one implemented a common gesture from the first elicitation study, and one with just any random gestures. So once again, 14 participants participated, this time equally, 7 males, 7 females, between the different ages of 24 to 60. So 11 of, it's very important that we recognize the statistics, because 11 of them had prior VR experience and 3 were newcomers. In the previous elicitation study, we kind of didn't take that into account. So the 8 participants had experienced the redirected walking within VR application as the only locomotion technique. So when we look at the procedure of this elicitation study, we did it the same way, where we introduced the participants to this VR scene, but then we kind of told them how to move to those specific objects, because there were different movement considerations, whether how would you move to the water tank, how would you move to the playing children, how would you move to the tree, how would you move to the donkey. So similarly, participants were informed of like different changing scenario, like children started to run, or there was now, it became from static to dynamic, or they were prompting or we prompted the participant to consider speed. Would you want to go fast to the donkey if it's actually running, or if it's going slow? And then similarly, we had them we kind of noted down all the gestures or interactions while the participants were in VR, recording inside VR and recording outside of VR. So when we look at the evaluation of the implemented locomotion gesture, so out of the 11 found techniques to move, the community was asked to choose 3 of them. So 50 community members were present, including the 10 that were involved in creating this locomotion techniques. So we found 11 different techniques, sorry, someone just my door. So we found 11 different techniques, and we showcased them to the community. So the facilitator kind of demonstrated each technique to kind of ensure accurate understanding and correctness, allowing participants to correct or clarify if needed. So the purpose was for us to actually have the community choose gestures for specific the next VR applications that we were going to be developing. Okay, so in terms of the results for the first elicitation study, we came out with 7 gestures, but some gestures were similar in movement, but different in orientation of the hand. Thus, we categorize them into mainly the five what is this, methods that you can see here. I just have a more graphical representation. I have a poll here. Sorry, it just popped up on my screen. Sorry. So we had categorized them now into these four gestures, which was the instant pointing. So weirdly enough, the instant pointing is kind of my favorite, because the instant pointing gesture is where participants kind of put their flat hand on the chest and then turn their hand and point it to the intended destination. They kind of do this to kind of say, okay, I'm moving there. And then the walking arms was just a continuous locomotion where they were just swinging their arms. So the funny thing is the hand tracking would often lose sight of their hands, because some of them will be walking a bit too fast, will be walking a bit too slow, or their hands will be too low. So that was one of the most common one, the continuous walking arms. And then the finger walk represented just the movement of the legs while walking, but using the fingers. So this was more of a continuous movement. Then the crawling and the pulling was somewhat similar in approach, but both the users reaching out in some sense, dragging themselves kind of closer. So some would pull or some would kind of crawl. So the overall difference in this matter of the finger behavior is that the pulling, seen as using a closed fist or the curl of the fingers, whereas the crawl was an open hand facing downwards. Okay. So with the second elicitation session, like I mentioned, there were about 11 that were found, including the ones that were also found in the first elicitation study. So 2 of them were kind of instant and 8 were continuous movement. One could function and one could kind of function as both. As the participants were told not to specify the use of their hands, 3 approaches were found without the use of hands. Having created a set of gestures, the participants were prompted to think of the speed and the distance in their movement and how to indicate that. It was also suggested that the speed of the control gesture should correspond with the speed of the movement in the VR. As you can see, the continuous one had speed control where you could kind of walk a bit slow or walk a bit fast. So most of the continuous ones had some kind of speed control. When setting the scene of catching up with the running children, for example, all 14 participants kind of changed their speed, but when asked about the methods that were far away, 12 participants kind of suggested a change of speed, whereas 2 either wanted to fly or be able to jump or instantly kind of go there because of the distance. So within the 11 discovered locomotions designs, it noticed that 8 out of the 14 changed their gestures when they were kind of confronted with this new end goal of how do you move to something that's far away. Okay, so now we're going into the selected gestures. So like I mentioned, during the evaluation, we kind of had presented all these 11 locomotion techniques, and 3 of them were ideally chosen. They were all hand gestures, and they wanted to keep the pulling one, the continuous pulling one, but they wanted it to work for kind of both hands as originally planned. However, for some reason in the prototype, when it was initially tested on the developer, both hands were working. But when we went to go test it in the community, we kind of never actually tried to figured out why it was only working for the right hand and not for the left hand. So the other gesture that was implemented or chosen was the walking and the running arms, where you kind of move your arms side to side, like in the real world. And then the last gesture was kind of the finger walking on. This one was mainly chosen because it was a favorite gesture. It was a favorite gesture and was easier for everyone to kind of do because it mimicked actual walking. Um, just to conclude that first study, the study kind of contributed and stressed the importance of kind of including users, because our main focus was we need non-expert users to generate gestures for movement or gestures in general. And because this makes us create them from a natural point of view instead of that awkward pinching, because who pinches to select something, right? We also have identified new gestures which could control locomotion in VR, which are context dependent, and allow for control variation of speed, because most gestures for locomotion in VR don't take into account speed because it's always instantaneous. Um, and once we kind of have all these gestures, once we had all these gestures implemented and validated, the gestures can kind of serve for in various VR applications across the globe. So looking into my next study or project, this is going to be very short because it's my honors research proposal. So this is actually my project that I'm kind of leading. So I'm looking at converting a cultural VR experience into a learning virtual reality experience. Just to start it off, I'm going to introduce you to the other VR experience that we're currently developing, which is what we nickname the Himbaverse. So it's a cultural VR reality experience of the Ovahimba community. And this VR universe would kind of transport a user into the vibrant world of the Ovahimba culture. Essentially, you'll just be in an Ovahimba village. So it just showcases a lot of different cultures of their tradition, such as the thing of like creating a storage unit, right? So each and every element of the Himbaverse will kind of be sourced from what we have as the Indigenous knowledge repository, where we have these multiple recordings, multiple validated models of every single aspect of the Vahimba culture. So by fostering this interactive engagement and understanding and appreciation, the Himbaverse kind of aims to honor the indigenous knowledge of the Ovahimba in an innovative way. And it also kind of offers this very unique way to kind of explore and safeguard the indigenous knowledge of the Ovahimba people through this immersive medium, which is VR. So my overall study just suggests that there has been an growing interest in utilizing VR for the preservation and the transfer of indigenous knowledge. So cultural VR experiences kind of offer this immersive and interactive environment, which kind of enable exploration and interaction with these diverse cultures and traditions. And through this immersive cultural, or I mean, although these immersive cultural experiences exist, we actually don't know if there's actual learning taking place, right? Because it was not specifically designed with learning as an outcome. It was designed for people to immerse themselves and kind of feel as if they're experiencing anything, but they're not actually learning, or we think they are not actually learning. So my main research focus for my honors would be kind of understanding how to kind of effectively support learning in cultural VR experiences and implement a learning support either through NPCs, virtual guides. It just depends on the exploration that we kind of explore and what comes out of the design. So my research approach would be a research by design method, where I will be using primary school learners from another a PPS interactive tech library, which is another research base that we have here in collaboration with a primary school in Namibia. So with the children, I'll kind of be designing these different learning supports according to them. So as you know, people have different learning methods. Some are visual learners, some learn through hearing, all of those things. So we'll be kind of designing different ones, and I will choose the easiest one to implement because it's just at honest level. And I would have multiple prototyping and evaluations with the children. But the main objective is just to kind of refine learning supports to cater to specific learner needs. That's kind of going to be my bigger PhD and my bigger master's and PhD, because I want to be able to integrate various learning supports into cultural or these existing cultural VR experiences and new cultural VR experiences, so we can kind of facilitate this knowledge acquisition, knowledge preservation, and all of those things. So the main goal is currently to contribute to the development of this cultural VR experiences for learning about indigenous knowledge, and also enable this formalization and integration of IK into the school curricula. So that's how I have the co-designing with the children and the co-designing with the indigenous community come full circle. Just to conclude, the integration of VR into the preservation and dissemination of IK presents really, it's a very powerful way for learning and formalization. So through this immersive cultural VR experience, like the Himbaverse and other projects that we have, individuals can really engage and learn about these diverse indigenous cultures. So by focusing on designing and implementing a learning support within these experiences, sorry. Okay. Particularly with primary school kids, we kind of aim to formalize this IK within educational settings. With that, I think I've come to the end